So let's take a look here now at example number 3. And we'll use these notes that we talked about in the last video to kind of help us think through this question. Notice here I'm forcing our hand to use the cylindrical shell method to find the volume of the region enclosed by these curves. So I'm going to go ahead and start to sketch out what this will look like. But again, since I'm going to be forced to use shell method, I'm not going to bother sketching the full 3D solid. It's just not going to be worth my time. So over here, let's see. I'm going to go ahead and say that if I have my square root of x, which looks like this, y equals 0, which is my x-axis, and x is equal to 1. Let's suppose that that goes right through here. Well then, I can start to see really quickly what my region looks like. Here's my region. And I want to rotate around the x-axis for this question. Okay, no problem. I'm quickly going to note that my intersection point up here is really easy to find because notice I would just have to plug 1 into my function square root x to find the y value for this point. And so clearly that point has y value 1. Now if I want to go ahead and start to sketch out my shell, I can remember right up here that my shell, then the starting rectangle for it, must always be parallel to the axis that I'm rotating around. So notice here, since I'm rotating around the x-axis, I can start with a rectangle that's going to be horizontal. I want it to be parallel to what I have down below, parallel to that axis. Now once I have this, notice that I can immediately start to create my mirror image duplicate. I can play connect the dots, and I can see that I'm going to have a shell here, but it's on its side. It's like it's ready to roll away from us. But that's totally fine, because I can note now a couple things immediately about this question. If I had to draw my starting rectangle like this, that was horizontal, I kind of had to pick some y coordinate to draw it at, some height. And I could have picked a lower height or a higher height, right? I mean, there's lots of other horizontal red lines I could have drawn. But that kind of shows me that since our starting rectangles would stack vertically, right? They would be above or below each other. This is a dy question. I have to tackle this in the dy direction. I don't have a choice in that. That's forced upon me. Well, now I can go ahead and start to measure out everything that I need, like the height and my radius, but I just have to make sure I do that in terms of y coordinates. Now, of course, before I do that, I'll go ahead and take my function here of y equals x, or root x. Remember, I'm going to have to convert that to an x equals, which here is pretty easy. That just gets me a y squared. So I can go ahead now and start to label on here that this side kind of now stands for my height. You kind of have to imagine what it would look like if you stood this cylinder back up. But this side here represents my height, and my radius, notice, would actually be right here. Notice I have to go back again into the original region in order to get this. So I can say that we see that the height here would be measured again by x-coordinates. I would use the x-coordinate over here on the right side and minus the x-coordinate that's over on the left side. Well, that's kind of strange. The x-coordinate on the right side is 1, so that's pretty easy. The x-coordinate on this side, like, I don't know what that x-coordinate is. Oh, wait a minute though. It's bounded by this function, or it's on this function. And so here I know that that x-coordinate is always going to be given by y squared. Perfect. We also have then r. We need to find how long this line segment is. And again, I need to try to use y values to do that because it's vertical. The y value up top is, well, a mystery y, and the y value on bottom, well, that's just 0. Again, you don't have to write the minus 0. So this means that my volume here is going to be given by 2 pi times my r times my height dy for the added thickness, and my bounds are going to again represent where my starting rectangles could have actually existed, how low to how high. And according to the picture, it looks like the bottom of my region was at y coordinate 0, and the very tip top of my region was up at y value of 1. And so this represents an integral that would actually compute the volume of the region using shells. Again, I'm not going to evaluate this, but I'll leave that for you to go ahead and tackle. You should be able to confirm you get a value of pi over 2.